This is Pearson Edexcel International Advanced Level Mathematics Mechanics 1, January 2023. First question is, a train travels along a straight horizontal track between two stations A and B. The train starts from rest at station A and accelerates uniformly for t seconds until it reaches a speed of 20 meters per second. The train then travels at a constant speed of 20 meters per second for 3 minutes before decelerating uniformly until it comes to rest at station B. The magnitude of the acceleration of the train is twice the magnitude of the deceleration. On the axis below, sketch the speed time graph to illustrate the motion of the train as it moves from A to B. So, first, on the vertical axis, this is meters per second. On the horizontal axis, this is time in seconds. So, important things you'll have to mark here. 3 minutes. So, change this 3 minutes to seconds. So, 3 multiplied by 60, 180 seconds. Another important point, the magnitude of the acceleration is twice the magnitude of the deceleration. For the speed time graph, first for t seconds, it is accelerating and reaches a speed of 20 meters per second. And then constant speed of 20 meters per second for 180 seconds. And then decelerating uniformly to rest. So first of all, I draw the line which is for the acceleration. So this is for the acceleration. First there is acceleration and reaching a speed of 20. And this is for t seconds. Then there is uniform speed, and this is for 180 seconds. And then decelerating. So the magnitude of the acceleration is twice the magnitude of the deceleration. So you can do it directly, or I can show the working for this. So the time taken for deceleration would be twice that of acceleration, because the acceleration is twice the magnitude of that of the deceleration. So I can justify this thing why this is 2t. So why this is 2t. So this justification is something like this. Like if we talk about the acceleration is a, and for the speed time graph, it is rise over run. So 20 over t is the acceleration. If 20 over t is the acceleration, then the deceleration would be half of this. So minus 10 over t, because deceleration, the magnitude is 10 over t and the deceleration minus. So I can use 10 over t, the magnitude, and if you mark this as t1, so this is basically again fall over run. I can say 20 over t1 is equals to 10 over t, or you can use the negative sign on both sides. So by simplification, t1 is coming as 2t, negative goes with negative, and 10 to the 20. So this is 2t. In this way, you can justify why this is twice. And you can do this directly because the initial is 20 and initial is 0 and 0 to 20 and then 20 to 0 again. So the magnitude of the acceleration is twice. So the time taken for deceleration would be double of that. So you can do this directly. This is the first part is on the axis, sketch a speed time graph. So we have the speed time graph here. Next is find the value of t. Find the value of t, and before that, there's important information given that the station A and B are 4.8 kilometer apart. So 4.8 kilometer. So change this to meters because of meter per second on the vertical axis. So 4.8 multiplied by 1000 is equal to 4800 meters. Now, find the value of t. The total distance is, so we know that uh, first find the value of t. A part is the graph. For B part, for A part, for I can show that this 3 minutes is 180 seconds. I use this in the graph. For B part, there is 4.8 kilometers, and this is 4800 meters. And for this part, I am using that basic information that for the speed time graph, the area is the distance, and the distance is given as 48 meters, 4800 meters. So the area under the graph. So this shape is a trapezium. This shape is a trapezium, and for this trapezium, we have 180 here, and the total is from this end to this end is t plus 2t is 3t plus 180. So you can find the area of the triangle and then rectangle and then triangle again, or you can apply the formula for the area of the trapezium. So here I'm using the trapezium. So the distance is the area, or the area under the graph is the distance. This is for the speed time graph. So half into sum of parallel sides, area of trapezium. This is basically the area of trapezium is equals to 4800, half into sum of parallel sides. So the parallel sides 180 is one, and the 3t plus 180 is the other. The sum of parallel sides. Sum of parallel side is 180 plus 3t plus 180 into the distance between them, between the parallel sides. This is 20. So 20 is equals to 4800. Simplifying, 3t plus 360. This goes with 2. How many times is 10 times? I can further divide by 10. So simplification, you can do this in any order. So on the right hand side, when we divide 4800 divide by 10, so 3t plus 360 is equals to 480. So 480 minus 360, 3t is equals to 120. So if it is 120, then divide by 3. If we divide by 3, we have the answer for the t value. So question was to find the value of t. So t is equals to 40. So the value of t is 40. We have the question. Answer for this part B. C part is find the acceleration of the train during the first t seconds of the motion. This is for 2 marks. Find the acceleration. Acceleration is simple. As we have the value of t is 40, so this t is 40. I can write 40 over here. So this t is 40. So using the idea that for the speed time graph, uh, acceleration is the gradient, or gradient is the acceleration. So gradient is the acceleration. So I can write a, and the gradient is simple, rise over run 20 over 40. So this is 20 over 40. So a is equal to 1. So acceleration is 1 over 2 meters per second square. This was question number 1. Question number 2. Two particles A and B are moving in a straight line in the opposite direction, uh, towards each other on a smooth horizontal surface, and they collide directly. So particle A has a mass of 3 mkg, and particle B has a mass of mkg. Immediately before the collision, both particles have the speed of 1.5 meters per second. Immediately after the collision, the direction of motion is unchanged, and the difference between the speed of A and speed of B is 1 meters per second. So is unchanged. The other is changed. It means other is changed. So uh, find the speed of A immediately after the collision and speed of B immediately after the collision. Second is find in terms of m the magnitude of the impulse exerted on B in the collision. So there are two particles, one is A, the other is B, and both are moving towards each other. So I can draw for this part A. There are two particles A and B, and these two are moving towards each other. So this is A and this is B. This has a mass 3 mkg. This is mkg, moving towards each other. Immediately before the collision, it was moving with 1 meters per second and 1 meters per second. And after the collision, this is the situation before the collision, and after the collision, the the direction is unchanged. So this is J. Now B is moving the opposite direction, and the difference between the speed of A and B is the difference between the speed of A and B is 1 meter. So if one is V, the other is V plus 1. So the important technical point is which one to take as V and which one to take as V plus 1. So the both particles moving now after the collision towards right. So V is here, and V plus 1 is the other. V and V plus 1. V and V plus 1 meters per second, meters per second. So the point is that why can't we take, so these were the two particles, A and B. You can't take for A V plus 1, because if V plus 1 is the speed after the collision of A, then that makes no sense, because the particle which is ahead is moving with V, and the which is coming from behind is V plus 1, obviously they will collide again, or this is not a logical thing. So in this case you'll have to take the speed of A as V and the other as V plus 1, because they are moving towards right after the collision. So obviously the particle B will be the speed greater than that of speed of A. So V plus 1, the difference is given as 1 meter per second. So V plus 1 is for B. Now here I can use the conservation of momentum. So by conservation of momentum, by conservation of momentum before collision is equals to momentum after collision. So let this is V, the other would be V plus 1, the difference is 1. So here I can apply the conservation of the of momentum principle. So before and after. So simple. M1U1 plus M2U2 is equals to M1U uh, 1U V1, sorry, plus M2 V2. 3M into 1.5 3m into 1.5, 3m into 1.5, sorry, plus m into minus 1.5, because coming in the opposite direction, minus 1.5, I'm taking the rightward direction as the positive, reference as the positive, 3m into v plus m into 1 plus v. So we have common m throughout, so you can simplify directly or you can take common. So here I can do it like this. This m goes with this m, and this m. We are left with, because 4.5 minus 1.5, 3v plus 1 plus v, 3 is equals to 4v plus 1, 4v is equals to 2, and v equals to 1 over 2. So if v is 1 over 2, so speed of A was v meters per second, and v is there 1 over 2 meters per second, and the speed of B is v plus 1 meters per second. So adding 1 to this, so 1 over 2 plus 1 is 3 over 2 meters per second. So these are the answers. Question was find the speed of A immediately after and speed of B immediately after. So this is part 1, A part 1, and this is A part 2. So here, let the speed of A, so A and V and V plus 1, these are the speeds. So second part is find in terms of m the magnitude of the impulse exerted on B in the collision. Exerted on the B in the collision. Now for your understanding, I can draw this figure again. So this was A, this was B. It was moving with 1.5 meters per second. It was moving here towards A with 1.5 meters per second, and here we have the value of V now. So this is 1 over uh, 2 meters per second, and this is again here 3 over 2 meters per second. Question is find the magnitude of the impulse exerted on B. So relative to any particle you can find, but on B, so I'm just showing the forces acting here. So impulse on B, so this is impulse. This is the impulse on B. So just concentrate or focus on the figure which I'm highlighting for the impulse. So impulse is the change of momentum. So the change of momentum. So impulse relative to is the change of momentum. Momentum after, momentum before. So I mark this red arrow towards right. And yes, after the speed is towards right. So I can write here 3 over 2, change of momentum, final momentum into this was of m kg. This was of m kg, m kg. So m into 3 over 2 minus momentum before m into minus 1.5. m into minus 1.5. I can write 1.5 for this as well. Now, momentum after minus, so change of momentum. Impulse is the change of momentum. So this is after, this is before. So the after it is same as in the direction of the impulse, because after the collision, impulse is towards right for the particle B. So this is 1.5 m plus 1.5 m, which is 3 m newtons seconds is the unit for the impulse. So impulse is 3m. This was question number 2. Coming to question number 3. Particle P is moving with a constant acceleration of uh, 3 minus 5 plus j meters per second square. At time t, consider the p has the velocity of 14I minus 5. So this is the initial velocity. Find the speed of p when time is 2. So simple. A part is you're given the acceleration. So you're given the acceleration for this part, and that acceleration is minus 4I plus j meters per second square. Initial is 14I minus 5j meters per second. The time is 2 for a part. So, and the question is find the speed. So first we'll find the velocity, and then you can find the speed by finding the magnitude of that. So V equals to U plus AT. V is V. U is the initial 14I minus 5j and plus A minus 4I plus j, and 2, simplifying this velocity expression, minus 5j minus 8I plus 2j. Or you can do otherwise, you can first find the magnitude and you can. So I'm doing this way. So 14, and this is now 6I minus 3j is the expression for the velocity vector. So find its magnitude, because speed is the question. In the magnitude ke liye we can write this symbol. The formula is simple: 6 square plus minus 3 square. So we have 36 plus 9, which is 45, which is root 45, which simplifies to, you can use calculator, or this is 3 root 5, or even if you write 6.7 meters per second, still okay. So speed is there. One important thing that if we just read these instructions, that whenever the numerical value is required for g, that must be 9.8 meters per second square, and give answer to 2 significant figures or 3 significant figures. So either you leave your answer for 2 significant figure or 3 significant figure. So I can write 6.7, or you can write this answer to 3 significant figures if you want to write. So this is the speed. This is the speed. For this case, find the speed of the particle. Second part is find the size of the angle between the direction of I. I we know is here towards right, and the direction of motion of P when time equals to 2. So we have the velocity vector when time equals to 2. So this is part B. For part B, we have the velocity vector when time is equal to 2. The velocity vector was 6I minus 3j. Question: find the direction between I. I is here. This vector is I. Now what I can do, I can for the angle between, find the angle between, size of the angle between I and the direction of motion of P. So the velocity is there. What I can do, I can complete a triangle. This is basically 6 minus 3. So move towards right and downwards. So right 6 and downward 3. So in this way, we have this vector, and this vector can be 6I minus 3j. So angle between I, so this angle theta is question mark. So obviously I move towards right 6 I move towards right 6. This is I, just for your reference. I'm writing here I small, and then I move 3 units down. So I can write here 3, but angle is here. So you can simply recall the tan ratio because uh, opposite over adjacent or perpendicular over base. So here I can write for B part. This is working for B part. Tan of theta is equal to tan of theta is equals to 3 upon 6, and theta is equals to tan inverse 3 over 6. Let me use the calculator. 3 over 6 inverse tan is 26 point. So theta is 26.565. So either you write 26.6, or if you write theta equals to 27, it's much better. So this is the answer. This is the answer. Or if you want to measure this angle, so this is the angle which I measured clockwise. You can also measure the angle like this. Like if what is this angle? So obviously 360 minus 27. 360 minus 27 is 333. So any answer is acceptable. So better to write 27 here. This was part B. And the last part is at time t seconds, P is moving in the direction of 2I minus 3j. This is the direction of motion of the particle when time equals to t. Find the value of t. So for this, first we need to find the expression for the velocity in terms of t. Expression for the velocity in terms of t. So expression for the velocity in terms of t means, so this is part C. Velocity is u plus at. So velocity is v. Initial was 14I minus 5j. If you remember, a was minus 4I plus j. Everything is the same. In the previous part, I used t equals 2 because of the question, and here it is t. So question is when the time is at the time t seconds, p is moving. So rest of the same, but only the time is different. So at time in the previous case it was 2. So when time equals to capital T, it is moving the direction of 2I minus 3j. Find the value of t. So we can simplify this first. 14I minus 5j minus 4ti plus tj. I can rearrange them, writing all the items sideways, and plus tj minus 5j. So 14 minus 4t, if you take I common, and t minus 5 and you take 1. So V is here. V is here. V is here. T minus 5 and 14 minus. The question, important point is that moving in the direction 2I minus 3j. So as P at this point is moving in direction of 2I minus 3j, 2I minus 3j. So as moving the direction means they are parallel. So what you can do, you can use the concept of ratio parallel. So you can divide I by I. The ratio is the same. The ratio is the same. Ratio same means, I mean to say the ratio same means the ratio of I to j is ratio of I to j of the direction. So same ratio. So same ratio. Same ratio means 14 minus 4t over t minus 5 is equals to 2 over minus 3. The ratio is the same. You can simplify minus 42 plus 12t is equals to 2t minus 10. Further simplification will give you 10t is equals to minus 10 plus 42. 10t is equals to 32. So t has the value 32 over 10, t is equals to 3.2. Question was to find the value of t. Yes, t is here. So this was question number 3. Next is question number, yes, important question of moments. Here, a branch AB of length 1.5 meters rests horizontally in the equilibrium. So I'm going to highlight the important points here. Two sports are at C and D. AC is 0.24 and DB is 0.36 as in the figure. When force 150 is applied vertically upwards at B, the branch is on the point of tilting about C. Tilting about C is on the point of tilting about C. So if it is on the point of tilting about C, so I'll explain it later. Okay, what does it mean? And when 225 is applied vertically, so this is vertically to upwards, and when this force is applied vertically downwards, is on the point of tilting about D. The branch is modeled as the non-uniform rod. So non-uniform rod means the center of gravity is not at the midpoint. So W Newton is the weight. The distance of from the point C to the center of the mass of the rod is x meters. So x is the distance of the point C, distance from the point C to the center of the mass. So I'm going to show here the forces and the lengths. Say we have over here, not exactly in the middle. So this is the center of the mass. This is W newtons. And the distance is x here. 0.24 here, 0.36 here. The total length is 1.5. So subtracting the sum of 0.24, 0.24 plus 0.36, subtracting it from 1.5 is 0.9. So this length is 0.9. This is 0.9 meters. Okay. Then obviously the last only this much is length. So this is 0.9. This is 0.9 minus x this length. So there are two conditions. This is first condition. This is second condition. First, I'll apply the first condition. Now, for the first condition, when the force of 150 is applied at P vertically upwards, the branch is on the point of tilting up. So it's on the point of tilting up. So over here, it is 150. So I'll draw two figures here. So here is the force which I'm applying here in the upward direction, and this is 150 newtons, and it is on the point of tilting about D. If it is on the point of tilting about C, it means that this point D is about to leave the support. Is about to leave the support means the reaction is here, the reaction is here. So this is the reaction at point C, this is the reaction at point D. So for this case, we have to take the reaction at D is equal to 0 because the rod is on the point of tilting about C. About C means that it's in equilibrium. So D is about to leave this support. So there is no connection. So at this stage, the reaction between the direction of the direction at point D is equals to 0. If it is about to it is about to move if it is on the point of tilting about C. So this is now the pivot. So tilting about D means this point D is about to leave the support. So we'll be taking RD is equals to 0. So if RD is equals to 0, then what you can do for the working, I can take the moment of this figure about C. So I'm using the first condition. So taking the moment about C, moment C. So if it is about C, so how many forces are acting? So RD is 0, W is there, which is at a distance of X from C. 150 is the other force, which is at a distance of, you can find the distance of B from uh, this point by subtracting. So this length from point D, B to the C is just 1.5 minus 0.24. This is 1.26. 1.26. So taking moment, so anti-clockwise moments equals to clockwise moments. So if we come to see it, W is clockwise. At W it is clockwise. So W into X. W into X is equal to, this is anti-clockwise, 150 into 1.26. 150 into 1.26. So Wx is equal to, so the important point, we should keep in mind that if it is on the point of tilting about C, in that case, we'll be taking the moment on the other spot as the reaction on the other spot as 0. Multiply by 1.26. This is 189, number 1. Next, for the next, I can take the moment, so I can delete this figure for the next part, and next I'll be showing other force. So for the other case, what I can do, I can delete this force. This force is not here. So, but on the other hand, we are applying another force which is of different magnitude, and this force is acting in the downward direction, and this force has the magnitude of 225 newtons. The measurements are the same. So in this case, when it is on the point of tilting about D, so in that case, will be, this is R, B. So in that case, you take the reaction at point C. For this case, when a force of 225 newtons applied vertically downwards at B, the branch is on the point of tilting about D. So in this case, take the normal reaction at C to 0. So we have the figure. Now, this time I'll be taking the moments now about about D. About D. Taking moment about D. So taking moment about D, this is anti-clockwise, this is clockwise, this is 0. So 225 multiplied by 0.36 is equals to W multiplied by 0.9 minus X. So we have, I'm taking the moment of T, clockwise moments equals to anti-clockwise moments. So W into 0.9 minus X is equal to 225 into 0.36. 0.9 W minus Wx is equals to 225 multiplied by 225 multiplied by 0.36 is 81. So Wx is equals to 0.9 W minus 81. So this is number 2. So there are two equations. We have Wx here. We have Wx again here. So solving 1 and 2. From 1 and 2, it is the value of Wx. So I can equate that was 189. 189 is equals to, so 0.9 W minus 81 is equals to 189. 0.9 W is equals to 270. 189 plus 81, whatever is here, you divide by 0.9. So W is equals to 270 over 0.9. W is equal to 300. You put this value simply in number 1. That was Wx is equals to 189. So 300 into X is equals to 189. So 189 divided by 300 is the answer. X is equals to 0.63. So we have both the answers here. So this was your question on moments. So in the important thing which you keep in mind that at one point you'll have to take the reaction 0. So if it is on the point of tilting about C, in that case you take the reaction at D equals to 0. If it is on the point of tilting about D, so in that case you take the moment on the other support as 0. So this is question on moments, question number 4. Next is question number 5. The points P and PQ are on the same horizontal road where PQ is a straight line. The point Q is between P and R, and PQ is 6x and QR is 5x meters. As in the figure 2, a vehicle moves along the road from P to Q with a constant acceleration. The vehicle is modeled as particle. At time t equals to the vehicle passes P with the speed of u. At time t equals to 12, the vehicle passes q with the speed of 2u. Using the model, show that x equals to 3. So simple. It is the question when it is at the point P, the speed is given. So the speed is u meters per second. And at Q, this point Q, it is 2u meters per second. So initial is u, the final is 2u, and the distance is 6x between P and Q. And time taken is 12 seconds from P to Q. So part A, P to Q motion. So I can write the data. U is the initial. Initial is given. Final speed is V is equals to 2U. The time taken is 12. The distance is 6x. So using the distance is 6x. The distance is 6x. TU. So you can use the equation. V is given. So distance is equals to S is equals to half U plus V into S is equal to 6x. So write down 6x is equals to half U is U finally is 2U and time is 12. I can simplify 6x 6 times here. So 3U into 6. 6 goes with 6 and we have x is equals to 3U, the first part. Second part is as the vehicle passes Q, the acceleration of the vehicle changes instantaneously to 1.5 meters per second. The vehicle continues to move with the constant acceleration 1.5 meters per second and passes R with a speed of 3U. So 1.5 is the acceleration. 1.5 is the acceleration for this motion. 1.5 meters per second acceleration and reaches here with the 3U meters per second. Okay. Next question is the vehicle continues to move and passes through U. Using the model, find the value of U. Find the value of U using this model. So motion from Q to R. Motion from Q to R. This is part B. This is part B. Motion from Q to R. Again, initial is given. U is equals to 2U. Final speed is given. V equals to 3U. The distance is given. S is equals to 5x. And acceleration is given 1.5. Using 2as is equals to v square minus u square. 2 into 1.5 into 5x is equals to 3u square minus 2u square. So we have on the left hand side, we have 1.5 multiplied by 1.5 multiplied by 5 multiplied by 2. 15. 15, 15, 15. X. Okay. Above here, the value of x 3u. So is equals to 9u square minus 4u square. The value of x is 3u. 15 into 3u is equals to 5u square. 45u is equals to 5u square. So I can show the complete working. It is basically 5u square minus 45u is equals to 0. 5 is common, u is common, inside is u minus 9 is equals to 0. As u cannot be equals to 0, so u minus 9 is equals to 0, u is equals to 9. Question was to find the value of u is equals to 9. So the value of u is equal to 9. For this part, the value of u is equals to 9. Last part is not find the distance traveled by the vehicle during the first 14 seconds after passing P. After passing P. So if we have u, you can find x. So the relation between x is equals to 3u. So as x is equals to 3u, so x is equals to 3 multiplied by 9. So x has the value 27 and maybe it's required in the next part. Coming to C part says that find the distance traveled during the 14 seconds, and when the particle was here, the time was 12. So, and for the first 12 seconds, you can find the distance, and 2 more seconds for in between Q and R. C part. PR, PQ, the distance between P and Q. The distance PQ is equal to 6x, 6 into 27. 6 into 27. 27 into 6. 162 meters is this much distance. 162 is this. 162 meters here. And after reaching this point, it's moving further from Q onwards. From Q to S. From Q to S, I can use a different from Q to S. Motion from Q to S. The time left is 2. The time left is 2. U at Q. U at Q, because here I can draw for your understanding. At Q it was 2U. U we have calculated as 9. So it is 2 9s are 18 meters per second is Q onwards. So initial is 18 meters per second, and acceleration we already know is 1.5. So you can use, and the distance from Q onwards is question mark. From Q onward is question mark. So S is equals to UT plus half AT square. S is S, Q onwards is equal to, I can mark this as S1. S1, U is 18, time is 2, half is half. A is 1.5, time is from Q onwards, because from P to Q it was 12, and is talking about 14 seconds duration. So answer is 36 plus 36 plus 3, 36 plus 3, 1.5 into 4 divided by 2. So we have 39 meters. So 39 meters here. It was 162 from P to Q and 139. So the distance moved, hence the distance traveled, hence distance traveled during first 14 seconds is 162 plus 39, so equals to 201 meters. 201 meters. Next question. Okay. A boat is pulled along a river at a constant speed by 2 ropes. The banks of the rivers are parallel to the boat traveling horizontally in the straight line, and the boat travels horizontally in the straight line parallel to the river bank. The tension in the first rope is 500 newtons and acting at an angle 40 degrees, as mentioned in the diagram, and the second force is of P newtons and the angle is alpha. Again, you can see in the diagram. The resistance is given, it's not mentioned. The resistance to the motion is given. So the resistance, I can mark it here, and this resistance is 900 newtons. The boat is modeled as a particle. The ropes are modeled as being light and lying in the horizontal plane. Using the model to find the value of alpha and the value of p. So simple working of resolving concept of the resolving forces. So I can resolve the force into components. These two components are there: 500 sine of 40, and this is 500 cos of 40. For the other, I can show with a different color by using a different color here and here, rightwards and downwards, alpha, p sine of alpha, and p cos of alpha. And that's it. Find the value of alpha and the value of. So what I can do, I can after resolving the components, and the important point is mentioned here, constant speed means acceleration is zero, acceleration zero means if you apply F equals to ma, the net force is equals to zero. So, or you can say the rightward force is equal to the rightwards equal to the leftwards, or any idea you can apply here. So you can say net force equals to zero. So here, first resolving forces horizontally and vertically. First resolve forces, in this case horizontally and vertically, horizontally and vertically. So, or you can say the parallel to the direction of motion and perpendicular direction. So any statement you can write. Instead of writing this statement, if I use a different statement, if I follow the statement of the language of this question, so resolve forces parallel and perpendicular to the direction of motion. This is the direction of motion. This is the direction of motion. So I have resolved the forces parallel and perpendicular direction of motion. So as moving the constant speed, so rightward forces, force in the direction of motion equals to the opposing forces, and so just apply this basic idea of equating the forces. So in the direction of, so as there is no movement in this direction or in this direction, so the forces which you can see in these two directions are basically equating, because it's not moving towards that river bank or towards this side, so it's moving in between. So and the forces are marked here and here, so actually these forces are balancing each other. So I can say p sine of alpha is equal to, I can write 500 sine of alpha is equals to p, sorry, 40, it was 40, p sine of alpha, or p sine of alpha is equals to 500 sine of 40 is first equation, and here the two forces towards right are 5, this was 40, 5 p cos of alpha towards right, and 500 cos of 40 towards right. So p cos of alpha plus 500 cos of alpha is equal to, force in the opposite direction is equals to 900, is equals to 900. Or if you apply F equals to MA, this is basically P cos of alpha plus 500 cos of, both are not alpha. This is 40, so this is 40. This is 40. 40 cos of 40 minus 900 is equal to 0 because the expression is 0. So from here, P cos of alpha is 900 minus 500 cos of alpha. I can mark this as 2. So the point is that I want to solve these two equations for P and alpha. This is very important technique here. So we have P sine of alpha on the left-hand side of equation 1 and P cos of alpha on the left-hand side of equation 2. So I can use a special technique, divide 1 by 2. Divide 1 by 2. Divide equation 1 by 2. So divide left side by the left side, P sine of alpha over P cos of alpha is equals to right hand side of this first equation is, so corresponding sides I'm dividing 500 sine of 40 over 900 minus 500 again, it is 40. Cos of 40. So this goes with this. We have tan of alpha is equals to, let us calculate the right hand side, 500 sine of alpha 40 over 900 minus 500 cos of 40. This answer is coming as 0.6216, so on. Inverse tan of this value is 31.8683, or I can write 32 degrees or 31.9 degrees. So both are correct. Now, P के लिए we can put this value in number 1, and the 1 was P sine of alpha. P sine of alpha is equals to 500 sine of 40. Sine of 40. P sine of 31.8683 is equals to 500 sine of 40. So sine of 31.86, so on. So 500 divided by, so my answer is coming as P is equals to 608.736, so on. So P is equals to, I can write 609 or 609, or better to write 610. 610 when we round it to significant figure, or 3 significant is 309. So 610, or a better answer you can write for this case. Next question, second last question, important question. A simple lift operates by means of a vertical cable which is attached to the top of the lift. The lift has the mass m, small m. A box Q is placed on the floor of the lift. A box P is placed directly on the top of Q, as on the figure 4. The cable is modeled as being light and inextensible, and the air resistance is modeled as being negligible. The tension in the cable is 42 mg over. So the tension in the cable is 42 mg over 5 newtons. The lift is and its contents move vertically upwards, and the acceleration here is 2g upon 5 meters per second square. Using the model, find in terms of m the combined mass of the boxes P and Q. The combined of P and Q. Let the combined of P and Q is m kg. Let the combined mass is uh, m kg for P and Q. The combined for P and Q is m kg, and the mass of the lift was already given as m. So what is the total? We can say uh, m combined mass P and Q. Mass of P and Q is equals to m kg let, and mass of the lift is equals to m kg. So what is the total mass of the situation? This is m plus m kg. So the total weight is m plus m g newtons. So m plus mg newtons. So the weight which is acting vertically downwards of the whole thing is, for the whole thing is m plus mg newtons. This is for the whole. Find in terms of m. So m, capital M is question mark. Moving upwards, acceleration is given. So this working is there. Total mass is so the total weight is so as moving upwards by Newton's second law. F equals to ma in the upward direction. The forces acting in the direction of the motion is the tension the cable 42 mg over 5. So 42 mg over 5 minus the total mass of everything equals to ma. A is given. A is 2g over 5. A is 2g over 5. Ag is 2g over 5. So I can simplify as g is common throughout. I can remove g throughout here. So g is here, g is here, g is here. The rest is 42 over 5. 42 over 5 is 8.4 m minus, I can open the brackets, minus mg. Minus mg is we have cancelled, equals to 2 over 5 is 0.4. So I can write 0.4 m plus m. 8.4 minus 1 is 7.4 m minus big M is equals to 0.4 m plus 0.4 small m. So I can simplify 7.4 m minus 0.4 m is equals to 0.4 capital M plus m. You can use other than capital M, you can use another letter. So then it is 7m is equals to 1.4 m. So capital M is 7m over 1.4. 7 over 1.4 is 5. So the answer is m equals to 5m. So question was combined find the combined mass of P and Q. So I can write combined mass of P and Q is 5m newtons. So 5m newtons is the combined mass. So this is answer to part A of this question. During the motion of the lift, the force exerted on the box P by Q is this. So this is the important point. The force exerted on P by Q is, so this is actually, I can, for this concept, I can draw a figure. So B part, I can draw, I'm not showing the cable, but this force is acting as the main focus is on point P, the force exerted on P. So I'm going to highlight only that part of the question, which is P is here. So the force exerted on P by, so this is actually the force exerted by Q on the, so 14 mg over 5, 14 mg over 5 is basically this force, 14 mg, 14 mg over 5 newtons of force exerted by P, by Q on P, and obviously already there's a weight for P which I can mark here, and question is, say this is MP question mark. Question is, find in terms of M the mass of P. So the whole situation was moving up and the acceleration was 2g over 5 meters per second square. So my entire focus is here on B, and just show the forces which are acting on B, on P. So the force acting on P by Q was 14 mg over 5, which I have marked it here in the upper direction. And the second is the weight of P, which is question mark. So in this way, you can draw the figure. So let me use, this is the force here. This is the force exerted by Q on P. And the whole situation is moving. So my focus is entirely here on this red block, using now by Newton's second law. On P. Moving up, F equals to MA. Force in the upward direction is 14 mg, 14 m g over 5 minus m p so mpg is the weight, is equals to m a . . 1 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10⁻⁷ 2 × 10 I can simplify. G is common throughout. Just ignore. Just cancel. We have 14 over 5 and 2.8 m is minus, you can minus mp is equals to 0.4 mp. 2.8 m is equals to 1.4 mp. So mass of P is 2.8 over 1.4. So MP is equal to 2m. Find in terms of m the mass of P. So P mass is 2m. So this part was the forces acting, the force exerted on P by Q. This was Q. The force exerted on P is 14 mg over 5. The weight of this P block, let this be equals to mp, then the weight would be mg, obviously mp multiplied by g. So again, this whole situation is moving upward with some acceleration. So using some F equals to ma. So for forces in the sum of forces in the direction of motion, the only force is 14 mg over 5 minus opposing force here. So my entire focus in the end was here. My entire focus was here. And there was weight and the upward force from on P by the Q. So in this way, you can find the mass of the PS plane. The last part is a parcel of 2 kg is pulled up a rough inclined plane by the action of the constant force. The force has a magnitude of 18, act in the direction of 40 degrees to the plane. The line of action of the force lies in the vertical plane containing a line of the greatest of the inclined plane. The plane is inclined 30 degrees. So this information is there. The coefficient of friction is given. The coefficient of friction is, this is the value of mu is equals to 0.3, and the model of particle parcel is modeled as a as a particle p. Find the acceleration of p. First part is find the acceleration of p. So acceleration of p, particle is moving up. Obviously, there's some acceleration here, and you can resolve the components. 18 sine of 40, and here is 18 cos of 40. There is a normal reaction which is perpendicular to the plane. So this is R and normal reaction. The weight is given as 2g is 2 kilogram was the mass. So 2g is the weight. So vertically downward is the weight. I can mark it here vertically downwards, like this. This is 2g newtons, and you can resolve further into the component. This is a routine working. So angle is 30 degree here. So 2g cos of 30 and 2g sine of 30 newtons here. And the coefficient of friction is given. So first we need to find the coefficient of friction, and then coefficient of friction as it is moving is pulled up. So friction is acting here in the opposite direction. I can write Fr for the friction, and I know the formula for the friction. The friction is F equals to mu R. This Fr is the friction. Let us write it Fr newtons. So friction we know is mu R. So mu is given, R we need to find, and R means the forces. So this plus this is equal to the force in the opposite direction. So here for part A, I'm just marking. So force in this direction are R plus 18 sine of 40 is equals to 2g cos of 30. So R is 2g cos of 30 minus 18 sine of 40. So in this way, I can use F equals to mu R. So friction is there, which is 0.3. The value of mu given 2g cos of 30, 2g cos of 30 minus 18 sine of 40. So I can further simplify. So friction is 0.6 g cos of 30 minus 5.4 sine of 40. You can use this value for the next part, or you can find this in decimals. So this is friction force and obviously acting in the opposite direction, opposite to the motion. Now, uh, question is find the acceleration. A is question mark. So A is question mark. So A meters per second square is the acceleration, which is question. So upward forces, so forces in the direction here. So these two forces were equal. So I just highlight these forces. I equated the forces because there's no motion in this direction. So R plus 18 sine is equals to, which is in the opposite direction, 2g cos of 30. In this way, I can find R, and then F equals to mu. I will give you the friction force here. Moving up, F equals to ma. So forces in the direction of motion. In the upward direction, it is 18 cos of 40, 18 cos of 40 minus the component of weight, which is 2g sine 30, which is 2g sine 30. Uh, and just highlight in the direction of motion, this is opposite and this is opposite. So 18 cos of 40 minus 2g sine 30, this force, and minus FR, minus 2g 2g sine of 30 minus friction is equals to MA, 2 into A is question mark. So 18 cos of 40 minus 2g sine of 30 minus friction, which we have just calculated here, 0.6 g cos of 30 minus 5.4 sine of 40 is equals to 2 into A. Let us calculate this. 18 cos of 40 minus 2 multiplied by 9.8, the value of g, into sine of 30 minus 0.6 multiplied by 30 plus 5.4 into sine of 40. So 2A is 2.3676 dot dot dot. Divide by 2 finally. So answer is A is equal to 1.1838. So acceleration is 1.83. So the acceleration was question mark. Acceleration is, so this is the answer. No, 1.83 meters per second square, or you can write 1.2 if you want to write to two decimal places. Second part is, this is answer to part 1. B part is find the speed of B as it passes through B. The point A and B lie on the line of greater slope of the plane where AB is 5, B is above A. B is above a particle P passes through A with a speed of 2 meters per second, and in the direction of AB, find the speed as it passes through B. So as it passes through B, so I can Just draw this, sorry, with the black. Say B is here, and say A is this point. The distance between A and B is given. The distance between A and B is given, which is 5 meters. And at A, the speed is given. At B, speed is question mark. And the acceleration we have calculated. Motion from A to B. Initial is given in the question 2 meters per second. The distance is given 5 meters. Acceleration is this value, which can be 1.1838. And V is question mark. So using 2as equals to V square minus U square, 2 into A 1.1838 into S is 5, V is question mark minus 2 square. Now using calculator, this is 11.838 is equals to V square minus 4, 11.838 plus 4, V square is the value. So V square is 15.838 and V is the square root, and the square root of this value is 3.976 dot dot dot. So V is equal to 3.98. So 3.98 meters. So this is at B. So speed of B as it passes B is 3.98 meters per second. And coming to the last part, the force of 18 is removed as the force 18 Newton is removed as at the instant P passes B. As a result, P comes to rest at C. Determine whether P will remain at rest at C. You must show all stages of your working clearly. So when the particle is here at point C, the string is removed, the force of 18 is now removed. If the force is removed here and the particle is at point C, so the force is the weight, which is 2g, and the two components are, as before, 30, 2g sine of 30 and 2g cos of 30, and there is no force. Force 18 Newton is not there. The force 18 Newton is not there. So here is the normal reaction. Previously, we added the component of 18 Newton force to the normal reaction, and we found the normal reaction, but here it is not same as before. So let us take it as R1. So R1 is simply 2g cos of 30. And so in this case, when the particle reaches here, so we'll find the friction force here. Mu will remain the same. So R is equals to 2g cos of 30. R equals to 2g cos 30. R equals to 2g cos 30. This is for C part. So for this case, R is simply 2g cos of 30. So friction in this case would be 0.3 into 2g cos of 30. There are different techniques for solving this question. This is 0.6 g cos of 30, or you can find this in decimals. So this value in decimals is 0.6 multiplied by 9.8 multiplied by cos of 30. This is the value of the frictional force which can act here, 5.0922. So 5.0922 newtons is the frictional force. So if this is the friction force which is acting, obviously at reaching at a point, it will try to move down when the 18 force is not there. So the friction force which can act here on the particle is 5.0922. 5.0922. This is 5.0922 is the force, and you can calculate the force, the component of the weight which is acting downwards. This is 2 multiplied by 9.8 multiplied by sine of 30. This value is coming as 9.8 newtons. This is 9.8 newtons. So the force which is acting in the downward direction is 9.8, and which is the force which is trying to stop this because of the surface is 5.0922. As the downward force is bigger, so obviously the particle will start moving in the downward direction. So from here, what is the conclusion? So we have, this is the force acting, this is the force which can act in the upward direction, the friction force, and the component of the weight, component of weight acting down the slope or down the plane is 2g sine of 30, which is 9.8 newtons, which is 9.8 newtons. 9.8 newtons. As 2g sine of 30, which is 9.8, is greater than the frictional force, which is 5.0922. 5.092. So it concludes that P, particle P, will not remain at rest. And here is the solution, I think, for the complete paper, January 2023. So the downward force which is trying to move it down, and the weight component is greater than. As the weight component is greater than the force which is trying to stop it, so we have this final statement there that it will not remain at rest, it will start sliding down, or the particle, or P, will start moving down the plane. Thank you.